Why do we actually care about the fact that our function is invertible? Well, let's imagine I have the following encryption function where I say that I want it to be 2x plus 3 modulo 26. The problem that I've got is, well, the GCD of 2 and 26 is very clearly 2, which is not 1. That means that 2 isn't invertible, mod 26. That means that there isn't going to be a unique inverse of this function. Well, what does that actually give me? Let's pretend that I encrypted the following. I encrypt or encipher math, M-A-T-H. That corresponds to the letter, or the numbers, 12, 0. T was something. Let me actually paste. Paste. Choop. T was 19 and H was 7. Okay, so I'm encrypting those numbers. So whenever I have E of 12, whoops, and that was 2x plus 3. And that means that I'm going to have 2 times 12 plus 3, which is going to be 24, 27. Reduce that mod 26, and that's congruent to 1. Okay, so math, M became the character B. E of 0 is going to be 2 times 0 plus 3, so that's just 3 mod 26. It's already reduced. E of T, that's 19, is going to be 2 times 19 plus 3, which 2 times 19 is 38, plus 3 is 41, which is congruent to, after the reduction, 15 modulo 26. Just subtract 26 from 41. Finally, E of the H, that is E of 7, is going to be 2 times 7 plus 3. That's the number 17. Already reduced mod 26. Okay, so those are our numbers. Now, if I try to recover this information, let's pretend for a second that for some reason we actually know what the encryption function is. And maybe that reason is because you're enrolled in this class and you're seeing that I'm doing it. In general, if you just get this ciphertext, you won't know what the encryption function is. But let's pretend that I told you this is my encryption function. So then you set to try to decrypt my secret message that I sent you. The secret message that I sent was 1, 3, 15, and 17. And you're like, okay, what did he send me? So what you would do is, in each of these cases, because 2 is an invertible, I can't actually find a unique decryption function. So instead, we'd actually have to solve the linear congruences 2 times what plus a 3 is congruent to 1 modulo 26. So then we'd do some algebra. Well, 2x would be congruent to, well, that's going to be minus 2 mod 26. Let's actually make that like 26. Take away 2 is going to be 24. Those are congruent. Mod 26. So then 2 times what is 24? Well, I know that x being 12 solves this congruence, but so does x equals to 25. Check this. But if 2 times 25 is 50, and that's going to be congruent to 24 mod 26. So check that work there. All right. What that tells me is that it was M, or it might have been Y. If I did the same game, 2x plus 3, and for what value is that congruent to 3 mod 26? Well, then I would have 2x is 0 mod 26. And yes, it's the case that x equals 0 is an obvious solution, but so is x equals to 13. Not that it's obvious, but 2 times 13 is 26, which is congruent to 0. Okay, so that means that it could have been A, or it could have been N. If I wanted to recover the third letter, I'd have 2x plus 3 is equal to 15 modulo 26. That would be the same as 2x being congruent to 12 mod 26. An obvious answer to that is x is equal to 6, or x is equal to 19. 19 being the t we wanted, 6 being the letter, G here. And then finally, for the last letter, 2x plus 3 is equal to 17 mod 26. Well, one of the answers would be 2x is 14. Again, mod 26, what values make this true? The obvious answer is x being 7, but the less obvious answer is x being 20. 2 times 20 is the number 40, which is congruent to 14 mod 26. Just subtract 26, confirm that. So the x equals 7 is the h character, and x equals 20 is the u character here. Okay, so what that tells us is the message that I sent you was either M or Y, A or N, G or T, H or U. So now we have 16 possible combinations of those letters. Maybe I sent you the English word math, or maybe for some reason I actually wanted to send you a message that was YNTU. Maybe that was meaningful between us for some reason. The point is, even when I know the encryption function, if the multiplier of the x, the coefficient of the x, is not invertible, there is no unique inverse, which means the message is not truly decipherable. We end up with something that even with perfect knowledge, we can't actually recover the message uniquely. And that's a bit of a problem. For this reason, our encryption functions should always be of the form where I have ax plus b. And this is if I'm dealing with an affine encryption function, but I mean, for an affine encryption function, I need it to be the case that the GCD of A and M is equal to 1 in order for A to be invertible, as we saw in the previous section. But any function, it's important that if I'm encrypting the information, I need to uniquely recover the information. So I need it to be that that function is invertible.